So we make a continuation, sorry, the video cut. So I'm starting from question number 3. So the diagram shows a simple pendulum that swings from A to B in 0.64 seconds. So this is the data that we obtained, the time 0.64, and the number of oscillation from A to B, that's a quarter oscillation. So we can find the period, because period is equal to time over the number of oscillation. So the time there is 0.64 seconds divided by the number of oscillations 0.25. So if you notice there, it simply means when you punch it into the calculator, 0.64 divided by 0.25, that will give you a 2.56. And remember, the SI unit is seconds. That's what we mean there. B, the frequency of oscillation, or the frequency of the pendulum. So remember, frequency is equal to n, the number of oscillation, divided by the time. So the number of oscillation in decimal point, I'm taking that. If you want, you can take 1/4, there's no problem. So it's 0.25 divided by 0.64. So what is that going to give you? If you look at that, 0.25 divided by 0.64, so that is going to give you a 0.39, and that is going to be in Hz. That is to 2 decimal places. Now remember what I said, it is the same even if you say frequency is equal to 1 divided by period, because you have already calculated the period, therefore you can know the frequency. So frequency will be equal to 1 divided by the period, which is 2.56. And if you divide 1 divided by 2.56, you'll be able to see to 2 decimal places, it will give you 0.39, and that is going to be in Hz. So you can see it is actually one and the same thing. Whether you use that or you use that, the answer is simply going to be the same. All right, I hope we are together. Let's look at our last question for this discussion. And this is going to be question number 4. So it says the figure below shows a simple pendulum suspended from a fixed point. So that's the fixed point there, which they have given you. The bulb is slightly pulled to position A. So it is slightly pulled to position A, then released. So therefore it will start to swing. Then the A part there, says that, state one factor that does not affect the period of a pendulum. So remember what we said, one factor that does not affect the period of a pendulum, we can simply talk about, mass of the bulb. So that is one of the factors. The mass of the bulb does not affect. Sometimes if the angular amplitude is very small, less than 10, it will not affect, the period of a pendulum. So the mass of the bulb, that was what you needed to write there. Then B says, if the values of time for 20 oscillations, so you can imagine now they're talking about 20 oscillations obtained where. So these are the values of the time for 20 oscillation. 16.1 second, 15.9, 16.0, 16.2, and 15.2 second. Then the question says calculate the period. So now the first thing, when they repeat the experiment several times that they have different time, you need first of all to find what we are calling as being the average time. So the average time t. So you need to add all the times, 16.1 plus 15.9 plus 16.0 plus 16.2 plus 15.8. Then this you divide by how many experiments were there. So there were 1, 2, 3, 4, 5. So we are going to divide that by 5 so that we can find the average time for all the 5 experiments that were done. So we can add all these, 16.1 plus 15.9 plus 16.0, just 16, plus 16.2 plus 15.8. So if you add all that, it is going to give you 80 divided by 5. So 80 divided by 5, that is going to give me 16 seconds. So I can say 16.0 seconds because they were left to 1 decimal place. So once you get that, this is the B part we are solving. So this is the average time. You can now use this average time to calculate the period of a pendulum, because you know that period is equal to time over the number of oscillations. So the time, you get this average, which is 16.0 seconds, and the number of oscillations, if you remember the number of oscillation, they told us the number of oscillation was 20 oscillations, so you divide by 20. So it is going to be 16 divided by 20, and that is going to give us a 0.8 seconds. So this is what you needed to do in the B part there, to calculate the period of the pendulum. Then after we calculate that, the question says calculate the frequency of a pendulum. That's the C part, calculate the frequency of a pendulum. So for the C part, remember frequency is equal to number of oscillation over time. The number of oscillation was a 20, and the average time is 16.0. So what is that going to give us in this case? So it is 20 divided by 16.0, or just 16, it will give you 1.25, and that is going to be in hertz. So that is what you need to remember. Now remember, alternatively, this is what I told you, that you can also say, because we calculated the period, remember the period was 0.8, so we can also say frequency can also be found by 1 over period. So the frequency can be 1 divided the period is 0.8 seconds. So if you divide that 1 divided by 0.8, it is simply going to give you 1.25 hertz. So this is the same value that we have also gotten from there. So you can use either this or that, there's no problem. Thank you so much for watching. If you like my videos, please, you can simply hit that like button. You can subscribe so that you can receive more video notification when new videos come through. Thank you so much for watching.